Hey everyone, welcome back to my YouTube channel. In this video, I'm going to be going over this LeetCode problem called Find the Duplicate Number. In this problem, we're given a list of integers. The list is called nums, which stands for numbers. And this list contains a certain amount of numbers, and the range for the numbers is from 1 to n. N is being the number which is one less than the amount of elements in the list. So for example, if this list has 5 numbers here, the range is going to be from 1 to 4 because 4 is 1 less than 5. Now, there's only one repeated number in this list, and so our goal here is to it's to return this repeated number. We have to return we have to find and return the duplicate number. And we can't modify the list while doing in this process. And we also have to use constant extra space, which means that the amount of memory we use can't depend on the input. So if a list is 5 numbers long versus like a million, the amount of space we use should still be the same. Now, here for the solution for this problem, what we're going to do is we're going to use an approach called binary search, which is where if we have like a certain list, for example, like 1, 2, 3, 4, 5, 6, then first we're going to search like the first half of the list and then the second half. And then then we can narrow it down to one of those two parts and keep repeating this process until we find the certain number that we want. So here we can use binary search to find the duplicate number. So for example here, what we're going to do is first we're going to define a minimum and a maximum. So here we start out with a minimum of 1 and a maximum of 4, because here just in this example that I made, which has 5 numbers, the maximum is going to be 4 because 4 is 1 less than 5. But here we just want to make sure that the min and max is basically like the range that we're given here, 1, n. Now, we're going to have a while loop, which is basically going to be running the whole program. And here, what we're going to do is we're going to create a variable mid, which is actually very important. It's kind of like the middle. I call it the middle is because the reason I call it the middle is because when you add min and max, minimum and maximum, and you divide it by 2, you get the you get like the number, you get the median, or not the median, but like you get the number in the middle. And so that's what we're gonna define this variable to be. So for example, if we have a list of 5 numbers here, the mid is gonna be 1 plus 4, which is gonna be 5. We divide that by 2, we get 2.5. That's like our mid for the first iteration only, because this while loop goes on for many iterations. So for the first one, this is what mid is going to be. And every new iteration, every new cycle, mid is going to be redefined based on the binary search algorithm. Now here, we're going to use list comprehension. Now list comprehension, it's like a much more convenient syntax of going through lists and then returning a certain conditioned variable. So for example, here we have for num in nums. So we're going to begin with the second part of this list comprehension. For num in num, this is just like a normal for loop. We're cycling through the list of numbers, but we're only going to return the numbers that are less than or equal to mid. Now the reason we're doing this is because the approach I'm using here is if we're given a normal list. So if we're given a normal list like 1, 2, 3, 4, 5, 6, right? Like 1, 2, 3, 4, 5, 6. That's like a normal list without any duplicate numbers. Now here, if we take just some random number like 3, here we're gonna count the amount of numbers that are less than or equal to 3. And so, for example, here we have 3 numbers that are less than or equal to 3. 1, 2, and 3. But if that number somehow surpasses 3, that means that there's a duplicate number in there. So for example, if we add another 2 here, now there are 4 numbers that are less than or equal to 3, and 4 is actually greater than 3. So the amount of numbers that are equal to or less than like 3, for example, that number should always be less than 3. If it's more than 3, that means that there's a duplicate number somewhere. So that's the approach that's like what we're gonna use to find the duplicate number. So here we're gonna add up just the amount of values that are less than or equal to mid. In this iteration, mid is gonna be 2.5 in this example, and so in this list that I've made over here, we have three numbers that are less than or equal to 2.5. 1, 2, and the other 2. So here we have 3 numbers that are less than or equal to 2.5. But now since 3, which is count represents 3 here, and mid represents 2.5. So since 3 is greater than 2.5, that means that there's a duplicate number somewhere in the list. So we're going to set duplicate to equal to mid for now. And then we're going to set max to be just 1 less than mid. The reason we're doing this is because this way we can this is how we can implement the binary search algorithm, because here I'm using this example again, 1 2 3 4 5 6. Now we can narrow it down to that the duplicate number is like it's only in the first part of the list, for example. We know that. So now we're gonna divide this half into another half, and then we keep going until we find just the singular duplicate number. Now, what if like the number of numbers that are less than the mid variable, less than or equal to, what if that's not greater than mid? So for example, here we have 3 is greater than 2.5. But what if is 2 greater than 2.5, right? So what if this if statement is false? Then we're just going to do the same thing, except it's going to be the inverse of what we did originally. So instead of limiting the search to one part of the list, we're going to limit the search to another part, the second half, basically here. So this whole conditioning block, what it's going to do is it's going to keep the binary search algorithm running. Now, eventually, when the while loop is exhausted, we're going to find the duplicate variable and we're going to return that. If we run this, we can see that this it's accepted because for every test case, this code works. Now, if you still don't understand why it works, let me try to explain it to you in more of like a simpler way. Essentially, when we're given a list with a certain duplicate number, what we have to do is we have to first like find the middle, the number that's the smallest number plus the biggest number, basically, and then we divide that by 2 to get like the middle number, the variable which is mid over here. That's what that represents, the middle number. Now that number, either it could be the first half of the array or the second half of the array. So if I have 2.5 over here, we can limit the search to, either it's the duplicate number is in here or it's in here. So that the mid variable kind of splices the list in half, so it's easier. We can kind of narrow down the search for the duplicate number. This is like the most efficient method, because we're not modifying the array at all, and we're using only constant extra space. So we are satisfying the requirements, and we're also using a very efficient way to find a duplicate number. So that was the code for this video. I hope you understood it. I hope you enjoyed it. And so that was it for this video. Don't forget to smash that like button, subscribe to my channel, and share this video with your friends. I'll see you in the next one.